Hi guys, welcome back to the channel. And today's Leetcode problem is K inverse pairs array. Okay, so it has asked by many companies here, and Google and Apple and Box applications has asked this question, and it's given as a hard problem in Leetcode. So this is a good problem, good dynamic programming approach here. We need to apply here dynamic programming. This is a dynamic programming problem here, and let us quickly dive into the problem. Okay, so let us understand the problem statement here. So for an integer array nums, an inverse pair is a pair of integers I comma j where 0 to lesser than equal to I, lesser than j, lesser than nums dot len, and nums of I is greater than equal to greater than nums of j. So we will understand this question. Okay. So given two integers n and k. So we have given with n and k integers, written the number of different arrays consist of number of numbers from 1 to n such that there are exactly k inverse pairs. Okay, so since the answer can be huge, return it to modulo. Okay, so let us quickly understand what's the question is saying. Okay, so let us take this as an uh, example case and let us visualize the question. Okay, so the question is saying, so you are given with n. Okay, so n means 1 to n integer is given, but we have to consider it as a 1 to n numbers. Okay, so and k is given, so k represents the number of pairs we need to make. Okay, so and the pairs must be inverse pairs. So what are inverse pairs means? So inverse pairs, so what are inverse pairs means? So we have to consider two indexes where I and j. Okay, so let us consider two integers. So a pair is said I comma j. Okay, I comma j is a pair where it is an inverse pair where I is lesser than j and ARR of I is greater than ARR of j. So when this condition satisfies, when these two conditions satisfies, then we can say it is an inverse pair. Okay, so we have to form an array. Okay, form an array with 1 to n integers. Okay, so here n is given as 3, so we need to form uh, 3 length array. Okay, so we need to form 3 length array with elements 1 to 3. Okay, from 1 to n. Okay, from 1 to n we need to form an array. So we need to form an array such that there exist k pairs. Okay, exactly k pairs. So we have to form an array such that we there exist k pairs. So this is like a permutation and combination, right? So we have to form these permutations, like these type of permutations, like array permutations can be 1 2 3. This can be this can be of any type, right? So it can be 1 2 1 3 2, and if we consider 2 and 1 and 3, this can be 2 3 1, and if you consider 3 as a first element, 1 2 and 3 2 1. So these might be the permutations of the of the array, right? So from these permutations, we need to find such an array, find such an array, find such arrays where the inverse pairs are exactly equal to k. Okay, so let us quickly check whether how many pairs are there in this. Uh, how many inverse pairs are there in this form of array? Okay, so here if you observe any, if you consider any two integers, there doesn't exist any pairs. Okay, so there doesn't exist any pair, so here it is 0. So if we consider this example, then what will be the uh, how many inverse pairs will be there? So if you consider 3 and 2 here, so there exists an inverse pair. So this 3's index is lesser than j's index, right? 2's index, right? And 3 value is greater than 2 value, so this is an inverse pair. So we can consider one as an, from this array we can say that there exists a one inverse pair. Okay, so and let us consider this thing. So if we consider this thing, okay, how many inverse pairs are there here? So 2 and 1. Okay, and so only one pair, right? So only one pair exists here. Okay, and if we consider this thing, so so if we consider this thing, we can also see that there exists one pair here, right? So here also exists one pair. Okay, and if we consider this thing, how many pairs exist? So if we consider this thing 3 1 and 2 1, here exist two pairs, right? So 2 1 is an one pair and 3 1 is an another pair, right? So these are there exist two pairs here. So if we consider this array, so there also exist two pairs, right? Here also exist two pairs. So if we consider this thing, 3 2 2 1, right? And 3 1 3 1 3 2. Here exist two pairs, and here 3 2 3 1 and 2 1. So here exist three pairs. Okay, so these are the inverse pairs exist in different types of permutations of an array. Okay, so we have to find such permutations where the inverse pairs are equal to 1. So how many permutations have inverse pairs equal to 1? So only two pairs, only two permutations have permutations of array have inverse pairs are equal to 1, right? So these two will be the answer for us. Okay, so when we see the pairs 1 3 2, so 1 3 2 and 2 1 3 are the are the formations or the permutations of an array where there exactly exist one pairs of inverse pairs, right? So we have found in this way. So how to achieve this? Okay, so how to achieve this? So from this we can observe that if we place one as our starting index, starting element, so how many pairs can we make by keeping one as an our starting element? So how many pairs can I make? So one as our starting element, how many pairs I can make? At most, so at most zero, right? So uh, by keeping one as a starting element, I can make at most zero, right? So at most zero elements, right? Zero inverse pairs, right? So because it cannot make any pair with these type of these elements, right? So it cannot make any pairs with these elements, right? So by keeping one as an starting index and trying to when we try to make pairs with other elements, we cannot make pairs with other elements, right? Because it is the smallest element, and we are keeping the smallest element in the starting index. So if you keep a if we keep a smallest element in the starting index, then we can make zero elements with that pair, right? With that index, right? So with by keeping one as a starting element, we can make zero elements. So if we keep two as a starting element, how many pairs we can make? So if we keep two as a starting element, we can make one and three. So if we keep one and three, so the remaining elements will be one and three only, right? So at most we can make how many elements? At most we can make one element, right? So because how many elements are there after this? uh, Before 2, how many elements will be there? So from 1 to that number, right? So from the 1 to that number, how many elements will be there? One number, right? So until one number, uh, until one we can make one pair with 2 as a starting element, right? So what if we take 3 as a starting element, and how many elements we can make? How many pairs we can make? 3 as a starting element. So we can make the remaining elements will be 1 and 2, right? So we can make how many pairs? So here we can make two elements, two pairs, right? So by keeping 3 as a starting element, we can make two elements, right? So if you consider one thing, so uh, for getting two, if we make two inverse pairs, this is not a valid answer, right? So we should not consider this thing. Okay, we should not consider this thing, right? Because it is making two inverse pairs. So this type of condition we need we must ignore here. Okay, so what we are doing here, so we are keep on increasing our starting element, right? So we are keep on increasing our starting element. So and uh, checking for how many elements it can make, right? So uh, what if, so here when we keep our starting element as 1, so the remaining so if we keep our starting element as 1, so pairs uh, how many pairs it can make initially? 0, right? So how many pairs I need to make now? So I need to make one pair, right? So I need to make one pair with the remaining elements, right? So by keeping the starting by keeping one as a starting element, I can make zero elements. So what I should do? I should do whatever I should do, whatever I do, So I should make I should make k pairs with the remaining elements, right? So I can make zero pairs with one element by keeping it as a starting element, and uh, um, and the remaining elements are what? So the remaining elements will be n minus one, right? So with n minus one elements, how many pairs I can make? I can make k, right? Because initially I make zero pairs, so I need to make exactly k pairs. So with n minus one elements, I need to make k pairs, right? So I need to make k pairs with these elements. So can I make the k pairs with these elements? Yes, I can make. So when I keep 3 and 2, so it will be 1, right? So with n minus 1 elements, I can make k pairs, right? So now with keeping by keeping 2 as a starting element, I can make one pair, right? So with remaining elements, how many pairs I should make? So with remaining elements, I need to make, the remaining elements are n minus 1, right? So remaining elements I can make k minus 1 elements, right? So initially I can make k minus 0 elements. So with remaining elements here, with remaining elements I can make k minus 0 elements, right? And with remaining elements I can make here k minus 1 elements, right? So I should make k minus 1 elements. Here how many I should make? So initially I made two pairs, right? And with remaining elements, how many I should make? K minus 2, right? So 1 minus 2, that is minus 1. So here we can, with n minus 1 elements, I should make k minus 2 elements here. Okay. So so here in this case, my what will be my k answer here? K will become to 0. Okay. And here what will be my k here? K can go up to k, k will be 0 here, k will be lesser than 0. So in these cases, what I need to return? In this type of cases, what I need to return? So at k is equals to 0, whenever k becomes 0, then uh, so whenever k becomes 0, I need to return what? Whenever k becomes lesser than 0, or uh, lesser than 0 or equal to 0, then have made the pairs successfully, so I need to return what? Return 0 here, right? So I need to return 0 here. So when k is equals to 0, I need to return 0 here. So from this I can make them one base condition, right? So, and here also, so after making these two elements, so I can make, let us consider, so we should keep on going in this way. So for n, uh, when I consider n as n, from n, how many pairs initially I can make, I need to consider. And from n minus 1 elements, how many pairs I can make? K minus whatever the elements previously we made, that elements, right? So from n minus 2 elements, how many pairs I can make? So from k minus previous, right? So previous space, right? So in this way we need to decrease, we need to keep on going decreasing, right? So what will be our function here? So f of n comma k will be equal to what it will be equal to? So it will be equal to f of n minus 1 comma k minus 0, right? Plus f of n minus 1 comma k minus 1, right? And f of n minus 1, uh, so here n minus 2 it will be n minus 2, and here it will be n minus 3. So n minus 3 k minus 3, right? And so on, right? And it will come up to 0 elements, right? 0 elements. So until it goes to 0 elements, we need to consider this function. So with this type of example, so by considering this example, uh, we made a function here. So this function, so to perform this thing, we need to run a for loop here, right? So we need to run a for loop, and we need to add our uh, I at 0 and 1 space, right? So if we add I here, and when we keep on going, and this will also become, initially it can go up to lesser than 0 or equal to 0, right? So let us consider it as a 0 comma 0 only, right? So this is what the function we need to calculate here. So this is how we'll be calculating this. And so let us try to find the recursive solution here. So one thing I can see, right? This can be achieved only by using recursion, right? So it can be also achieved by using top down approach also, but we will try to do it in a recursive way. Okay, so what are our base conditions here? So uh, so if you consider one thing, okay, so if another base case here is, so initially if k becomes 0, okay, and if k becomes 0, okay, if k becomes 0, what we need to do? So if k becomes 0, we need to make 0 inverse pairs, right? So we should make 0 inverse pairs, right? So how many pairs I can make with this? So in how many, like only the array 1 2 3, which consists of numbers from 1 to 3, has exactly 0 inverse space, right? So k is equal to 0 means, what is the array we can make? So k is equal to 0 means we need to make 0 inverse space, right? We need to form 0 inverse space. So what is the array uh, where there are 0 inverse space? That is a sorted array, right? That will be a sorted array, right? So whatever the n is, so that will be a sorted array, right? So if n is 5, then the array will be in this way, right? So there will be only one array which gives 0 as an inverse space, right? 0 as an inverse space. So we need to return 1 at this case. Okay, whenever our k becomes 0, then we need to return 1 in this case. Okay, so whenever k becomes lesser than 0, so minus 1 means it is not a valid case, right? So minus 1 inverse space we can't make, right? So in that case we need to return 0 here. Okay, so if k is lesser than 0, we need to return 0 here. And our n also can go up to, so our n also can go up to lesser than 0, right? So if our n, so if n can go up to 0 and 0 and lesser than n also, right? If n goes to 0, then I think then can go, if n can go up to 0 or lesser than 0, right? If n is 0 means, what is the condition? So if n is 0 means there are 0 elements we need to make, right? So with 0 elements we need to find inverse space, right? Which is an invalid case, right? So if n is 0 and k is something, right? If n is 0 and k is something, so with 0 elements we need to make these many k inverse space, right? This is an invalid case, right? So in this case also we need to return 0. And if n goes to lesser than 0 also, if n is lesser than 0 also, this is also an invalid case, right? Minus 1 element. See, this is not at all a valid statement, right? So if n is lesser than or equal to 0, also we need to return 0 here. We can make 0 permutations that forms these many inverse space, right? So so these are the base conditions we need to handle here. So let us quickly solve this function using solve this problem using recursive solution. Okay, using recursion here. Okay, so after recursion we will try to optimize this solution. Okay, so let us quickly solve this recursive solution. And here they said that it can go up to, the answer can be very large, so we need to return the modulo here. So let us quickly add our modulo here. 2 3 4 5 6 7 8 and 7. Yep, and we need to call our recursive function here. Solve n comma k. Okay, and public int solve int n comma k. Okay, so what are our base conditions here? So what are the base conditions? So our base conditions are this, right? We need uh, let us copy this and let us paste it here on. Okay, so let us modify this statement here. So let us, if k is lesser than 0, or n is lesser than or equal to 0, then return what? 0 here, right? So if k is lesser than 0 or n is lesser than or equal to 0 also, we need to return 0 only. Or else what we can do, we can we are at a valid case, so we need to find the number of permutations where there can uh, permutations of array where there can be k inverse pairs, right? So we need to find that. So with what elements, with we need to check whether with n elements we can make a k inverse pairs or not. Okay. So for that, what we need to do, we need to take an answer variable here, okay, which will calculate the answer for it, and we need to run a for loop here, okay, up to n, and answer answer plus equal to solve of n minus 1 of k minus I, right? We were going k minus 0, k minus 1, k minus 2, right? So here also we need to go k minus 0, k minus 1, k minus 2 in this way, right? So let us, and at last we need to return the answer. So let us quickly run this problem and let us see whether it is working or not. Okay. So it is working, right? So the recursive solution is working. So now we need to convert this recursive solution into a DP solution, right? So what are all the parameters here changing? So the both the n is changing and k is changing, right? So let us take a 2D DP here. So let us consider a 2D DP here, okay, with n plus 1 as a length and k plus 1 as a length, okay, and let us fill the dp with a or minus 1, okay. Let us fill every value of a dp with minus 1 here, okay. Arrays dot fill a comma minus 1. Oh, so I have successfully filled my dp with minus 1 and I am passing my dp here, okay. And here what I need to check, whether my dp value is present or not, right? If it is not equal to minus 1, then it is already being calculated, so we need to directly return here, okay. So if dp of n comma okay not equal to minus 1, then directly return dp of n comma k, right? Or else what we need to do, we need to we need to store that calculation in dp of n comma k, right? So we need to store that calculation in n comma k, right? So for as we need to apply modulo here, so I'm not doing the assignment operator here, I'm doing the uh, this thing, okay. So uh, and I need to apply modulo here, right? So I'm applying modulo here, okay, and at last I'll be returning dp of n comma k, okay. So let us also do mod here, and here also let us do mod here, and let us pass dp here, okay. This will be the solution here, okay. And but if you carefully observe here, we are initially storing our dp with minus 1, right? So our answer may go to 0, right? So our expected answer will come little bit less, right? So why? Because we are adding minus 1 to the original answer. So what will be the minus 1 plus original answer? If minus 1 plus 1 will be 0, right? So in case of 1 we are getting 0 here. So what we need to do here, we need to apply a ternary operator here, okay. If if dp of n comma k is equal to minus 1, then we need to uh, add a add 0 in the place of dp of n comma k in place of minus 1 here. So we need to add 0 here, or else what we can do, if it is not minus 1, then it is a valid answer, so we can add dp of n comma k, right? So in this way, if we apply a ternary operator here, in place of getting uh, a a lesser value, we will get an original value here, okay. So we'll get an original value, okay. So this is how we'll be applying a ternary operator and calculating the answer here, okay. So let us quickly run this problem. So it has passed successfully. So let us try to submit it. So it has passed the solution. Okay. So this is how we'll be calculating this question. And coming to the time complexity here, the time complexity will be how much? The time complexity will be n into k, right? So we are using a 2D DP here. So the time complexity will be n into k, right? So n into k, and n operations we are applying here, right? So it will be n square into n to k, right? So the time complexity will be how much? The time complexity will be big O of n into k, right? So this will be the time complexity, n square into k, right? So why? Because yn square we are using a 2D DP, and yn we are for every iteration we are going n, right? So for every iteration we are we are performing a big O of n operation here, right? So for performing that big O of n operation, we need to even add that big O of n operation also, right? So we are so for every iteration we are doing big O of n, right? So for n square, what we'll do, n square into n, right? So that will be the time complexity here. And coming to the space complexity here, so the space complexity will be big O of n square, right? N into k. Okay, the space complexity will be n into k. So this is the problem statement here. So this is how we'll be solving this problem. And thanks for watching this solution, and subscribe to the channel. Thank you.